be good. So with this first question, the other thing you also want to recognize about these past papers is that they always like putting the straight line with the parabola. It's such a cliche. It's the same thing all the time. I'm pretty sure after you've gone through quite a lot of past papers, you're gonna see that, you know what, these papers, they're just repeating the same things actually. So question 6 says the graphs of f, right, and g. So they have not given us the equations. They've just given us the standard forms, which is like, okay, that's nice. So you have f and g. D is a common point on f and g. So you have D here. It's a common point. So them telling us it's a common point, that's like, yo, don't even sleep on this. Otherwise, you're gonna cry. It's a common point, and then they said F intersects the y-axis at -3, okay, and at 2, okay. G is the tangent of F at G. So this is important. It's a tangent. So these keywords here, you're gonna see how, as we're gonna be answering these questions, we're definitely gonna be going back to these specific words: common point, intersects, and tangent, like legit. So for example, the first one, right? It's saying for which values of x is f of x below 0, below or equal to 0. Remember, f of x just means y. They're asking you where are the y values of f smaller or equal to 0 for 2 marks, of which your image, you can see where the y values are below 0. The y values are below 0 here. This is the part where your y values are below 0. So they want you to give the x values that are producing these negative y values. So it's clearly x values from -1. There we go. I mean -3, sorry, until +2. You see. So your answer for the first one here, you're gonna have to say x is an element of -3 until +2. The reason we're putting square brackets is because they're asking where is it smaller or equal to 0. It's equal to 0 at -3, and it's equal to 0 at 2. You see. So that's why here we are putting square brackets for the -3, square brackets for the 2. Moving on to the next question for 5 marks. They're asking us to get A, B, and C. A, B, and C, they're technically asking us to get the equation of the parabola. Now, you getting the equation of the parabola, it's really, really, really not something you should ever struggle with. The reason why you should not struggle with this kind of equation is because as long as you have your 2 x-intercepts and you need to get the equation of a parabola, this is what you do. So you have f of x, right? F of x is equal to ax squared plus bx plus c. Fine. Now the issue is, or the big idea here is, anytime this is factorized, it will always be in this format. You'll always have a here, and then you'll always have 2 brackets. This will be like x minus x1, x minus x2, always and forever, of which the x1 and the x2 there will literally always be representing this x value over here and this x value over there. And remember, whatever we're doing, you don't need to take any notes. You can just, view and see what's going on so that you can proactively think of questions that you may want to ask. Because if you're going to be like writing and looking, you're going to not be asking yourself certain questions that you may want to be asking yourself, so that you can like switch on your mic and ask those questions and be answered on the fly. But anyways, the x value here is a -3. So you're gonna have to be careful. If you're gonna throw a -3 here, remember you're gonna have a negative times a negative. So you're gonna have a +3 there. And then here you're gonna throw a +2. So here it's gonna be x minus 2. So here you have like 1 foot in the door. When I say you have 1 foot in the door, I literally mean that all you need to do for this question is you just need to now you just need to like FOIL out your brackets. So the way to do it is you're going to have here, leave the a outside. Don't worry about the a. Just multiply these 2 out. X times x is like x squared. X times -2 is like -2x, and then plus 3x, and then minus 6. So the idea is don't multiply, don't worry about the a. Like everything is all good right now. So this is going to be positive x and -6, and then f of x here. So the good news is, as long as you have your equation in this format, you're literally almost done. The reason why I say you're literally almost done is if you multiply the a inside your brackets, you're going to have ax squared, ax, and then -6a. And then this is f of x, right? So as long as you have this, you can clearly see that all you need now is to remember that, okay, fine, your equation is in this format, ax squared plus bx plus c. So you can clearly see that all you need here is to work out a value of a, because as long as you can work out a value of a, you will have something to throw there, you'll have something to throw there, and then your equation will be like done, you see. So for you to get a value of a, you only just need a coordinate that the graph passes through, because if you throw in an x value and a y value in this equation, you will be able to solve for a, and then the moment you solve for a, you will have your equation in this format, the whole thing, you see. This is where the point D comes in, because D is clearly an x value and a y value that the graph passes through. So in our equation, where x is, we're going to throw a 1. Where y is, we're going to put a -8 there. So this is going to be like -8. Going to throw a 1 there. Going to throw a 1 there. Going to throw a 1 there. So this is clearly giving us a plus a. Nope. There's supposed to be a here. Oopsie. It's supposed to be a. I was going to make a very, very nice mistake. So this is a plus a, and then minus 6a. And then here you're going to have 2a minus 6a. And then a here, it's like -4a, -8. And then you're going to have here -4, -4. This is like 2, and this is like a. And then now you are home free, because now you can say that therefore f of x is equal to, so where a is, you're going to drop a 2 there. Where a is, you're going to drop a 2 there. And then where a is, you're going to drop a 2 there. And then there is your equation. So here you can then say, therefore, a is a 2, b is clearly a 2, c is clearly a -12. And then they're going to give you how many marks are they going to give you? They're going to give you 5 marks. They're going to give you 5 whole marks for doing what it is that we've just done now. So having to have written out what we wrote in the beginning, that's something generic. It means that you're going to write, it's the same thing for all parabolas. You see, all parabolas, when you're going to factorize them, if they're factorizable, they'll always have 2 brackets, and you always have to put your a value outside there, and then you just got to do what you got to do. So these answers are all nice and dandy. We can move on to the next question, which is, I think, 6.3. 6.3. Let's see here. Let me crop this out. Do this. Do that. So it's something like 6.3, right? They want us to get the turning points of f. So getting the turning points, there are some questions you really need to make sure that you never ever get them wrong. Just make sure you never get them wrong. Otherwise, there's something wrong, you see. So it says here, we need the coordinates of the turning points of f, of which the coordinates of the turning points is just down here. You see, this is where the turning point is. So because it's a parabola, whatever it is, it doesn't matter. Anytime you need to get a turning point, parabola, cubic function, it doesn't matter. The easiest way to do it is to just differentiate and equate that equation to a 0. That's how you're going to get the x value of the turning point. But because it's a parabola, I mean, we could easily just use this formula to just get the x value of the turning point, which will give us -2 over 2 times 2. This is going to be -2 over 4, which is like -1/2. That's the x value of the turning point, right? Now, as long as we have the x value of the turning point, we can get the y value of the turning point as well. This is negative whatever. The y value of the turning point, we can just use our equation, as in where x is, we can throw there a -1/2, and then we're gonna have here 2 with a -1/2 squared. Oops, ran out of space. Hey, yeah, let me zoom in and write a bit smaller. F of x with a -1/2, and then we're gonna have a 2, -1/2 over a, and then a -1/2 over a, 12. In the calculator, let me see what we get here. It's 2 times -1/2 squared, and then you have plus 2 with negative a half. What is this thing now? 1 and 2, right? And then you have like minus 12. That is giving us negative 25 over 2. So this kind of looks accurate, negative 25 over 2. That's like negative 12 and a half, which kind of looks accurate because it's like all the way down here. And then this is telling us our y-intercept is like negative 12. So if this is like negative 12, somewhere here is below negative 12, which is like negative 12 and a half. So yeah, this is accurate. So your turning point, you can say, therefore, negative 2 coordinate, negative 25 over 2. They're going to give you the 3 marks, and you're going to go home with a smile, because why not, right? Like, why the hell not? 2 marks. They are talking, what are they talking about here? They said, write down the equation of the axis of symmetry of H. If H is this equation. So these are the kinds of questions where when you look at them, usually there's always like a reaction, but there's no need to react here, because look, what they're saying is H is a specific graph, right? It's nowhere on the sketch. However, H, you get it by taking the equation of F, and then wherever you see X in the equation of F, you need to put X minus 7 there, wherever you see X. And then once you do that, you need to add 2 to the whole equation. You see, that's what you need to do to get the equation of H. So before we even worry about answering this question here, we need to get the equation of H first. So let's do that. Let's get the equation of H. The equation of H, they said it is f of x minus 7 plus 2. So what that means is, in the equation of f, right? Let's get the equation of f first. Let's copy this. Copy. Remember, anything that's going to be said that's not straightforward, please just say something. So we want to write out what f of x minus 7 is. So let's firstly get this. Let's firstly find out what is f of x. What is fx minus 7? What is it going to look like? So you're always just going to use your f of x equation to help you, because all that's happening is in the equation of f, right? Wherever you see x here, over here, and over here, you have to put in what is here, you see. So what we have here now is x minus 7. So what that means is in the equation of f, we're going to have a 2 here, and then open brackets squared, another 2, open brackets minus 12. So in those brackets, we're going to have to drop there a negative, a 7, an x minus 7, and an x minus 7 here as well. Meaning we're going to have here 2, and then x minus 7, x minus 7. And then plus 2, x minus 7 minus 12. If you simplify this, this is going to be a long dry. You're going to get whatever you're going to get here, fine. But then I'm just going to give an idea of what this x minus 7 means, right? But then the issue is, instead of us just having x minus 7, we have x minus 7 here, and then the whole thing we have to plus 2. So the reason why this is a 2-mark question, it's not because they want us to do a bunch of algebraic stuff here. No, they want us to realize what is happening when we have a minus 7 here, and when we have a plus 2 over here. They want us to recognize what is happening to the graph. Because if they're asking for the equation of the axis of symmetry of H, firstly, what you want to consider is the axis of symmetry of the original graph first. Like the graph of f, right? Its axis of symmetry, it's all based on the x value of the turning point. So what I mean is, firstly, the x value of your turning point here, we worked it out to be like negative a half, you see. So somewhere at negative a half, like here somewhere, here you have your original axis of symmetry. The equation of this axis of symmetry is just x is equal to negative a half. Now the idea is, with H, the graph of H, they are just trying to tell you that you get it by moving the graph of f 7. This is telling you that your graph of H, right, is basically the graph of f after it has been shifted 7 units to the right and 2 units upwards. I'll repeat. H of x is the graph of f shifted 7 units to the right. After moving it 7 units to the right, they shifted it 2 units up. Now, if you're going to have a new axis of symmetry, you moving your graph up or down does not affect your equation of your line of symmetry. I'll repeat that just now. You moving your graph up or down does not affect your equation of your axis of symmetry. What I mean is, if you're looking at this original equation of f of x, this is your axis of symmetry, right? Your axis of symmetry is at -1/2. Now, if you move this graph up or down, your axis of symmetry will remain the same. So this shift up or down, or this shift of 2 units upwards, is not going to affect our axis of symmetry. However, them moving our graph 7 units to the right, this is definitely going to affect our axis of symmetry. Because if this whole picture is moved 7 units to the right, it means that the axis of symmetry is also moved 7 units right. You see, 7 units right. That's what this whole x minus 7 portion means. It means that the whole image was moved 7 units to the right. And then after doing that, they moved it upwards. But then this is irrelevant to this question here. It's irrelevant to this question because this question is mainly focusing on the axis of symmetry. So our axis of symmetry is just going to be 7 units to the right, meaning that from a -1/2, right, we just moved it 7 units to the right, meaning that it's going to be somewhere at 13/5. No. Yeah, no, 6.5. What is 6.5? -1/2 plus 7. I think it is 13/5. Let me just double check in the calculator. Plus 7. Yes, it's 13/2. You see. So the new axis of symmetry is going to be where x is equal to 13/2. I wrote over 3 there. I keep writing over 3. I meant over 2. There you go. This is going to be your new equation of your axis of symmetry, because your axis of symmetry is only affected by this. This is irrelevant. So this is not a question we need to work out algebraically, because if you work it out algebraically, you're going to waste a gang load of time. Because once you have your new equation, I mean, getting the axis of symmetry would be you getting the x value of the turning point, and then you getting the x value of the turning point. You see, it's just all the work unnecessarily. So if all this made sense, that's fine. If there are any questions, you can ask, but I don't think anybody wants to ask anything, which is all good. Let me see what the next question says. Paste this over here. Corrupt, and then it says 6.5. 6.5 says we should calculate the gradient of G.
Gradient of G, that is y is equal to mx plus c.
Y is equal to mx plus c. Or not. Oh no, or maybe. Well, that's okay. The equation is y is equal to mx plus c. That's the equation of G, right? But then they want us to get the gradient of G for what you may call for 3 marks. You see, so we have there G of x is equal to mx plus k. It's just a variable, but they want us to get the gradient of G. The issue with the gradient of G is that we only have one coordinate for the line G. So us just having one coordinate, it means that this formula here, we cannot use it. This formula is not useful to us because this formula needs us to have 2 coordinates. Furthermore, we don't have any line that it is parallel to, so this formula is useless. We also don't have any line that it is perpendicular to, so this formula is also useless, you see. And we don't have an angle of inclination, so this formula is also useless, you see. As long as you see that all these formulas are useless, you need to think of the first derivative. You need to think of a differentiated equation, because remember, the first derivative is a gradient equation, you see. So that's the gradient equation we need to think of. We need to think of a first derivative. However, we obviously need to make use of something that can give us this gradient over here. We specifically know that, okay, any tangent, remember we said here, this is important, as long as they've told us that G is a tangent to F, it means that the gradient of the parabola here is the gradient of the tangent. I'll repeat, a parabola and a tangent, or any curve with any tangent, they'll always share the exact same coordinate at a point where they meet, and then they'll also always share the exact same gradient, you see. Like that's why here with D, we're able to use it for the straight line graph, and we're also able to use it for the parabola. So in our question here, the gradient equation that we need to use, or the first derivative that we need to use, is the first derivative of the graph of F, because the graph of F is the only graph that can help us get the gradient at this specific point. We know that this specific point has an x value of 1, which is useful to us. But then what is more useful is the gradient equation that will get us the gradient at that point. And the only gradient equation that will get us the gradient at that point is the first derivative, because remember the first derivative is just the gradient equation. So the issue is we're going to just differentiate this to get a gradient equation. 2 times 2 is a 4, then remove 1 from there. 1 times 2 is a 2. Remove 1 from the exponent, you're going to have x to the power of 0, which is just a 1. So we can, it's just 2 times 1, which is a 2. Anytime you differentiate a constant, it just falls away. So this is our gradient equation, you see? Gradient equation. It's the only one that's helping us, because we went through all of them. All these were useless in this point, or in this question. So this is the only one that's useful. Now we know that this gradient equation is useful if you can give it a specific x value where you want to work out a gradient. So we want the specific gradient for this x value here, an x value of 1. Because if we get the gradient of the curve where x is a 1, it's the exact same gradient as the gradient of our tangent. Because in the tangent, because a tangent and the curve, they'll always have the same gradient at the point of intersection. So that's what we can do here. In the equation of gradient here, where x is, we can just throw a 1 over there. And then this is like 4 plus 2, which is like a 6, you see. And then here we are. The gradient is a 6 where x is a 1. So this is saying the x value is 1. The gradient is 6, you see. So therefore, the gradient of G, let's see here, therefore, the gradient of G is equal to 6. And then you're done. You're going to get your marks. Life is going to go on, and you are going to be happy, which is all that